Hey everybody, this is Larry. This is day 12 of the Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join my Discord. Let me know what you think. Uh, Today's poem is Word Ladder, and I'm still in Medellin. I'll try again next time. But yeah, Word Ladder, which is a way. I feel like I've done this like 4 times to be honest, so it's not that so I'm trying to figure out like how to say it. I mean, this is basically shortest path in the graph. There's n words and technically maybe n square edges depending how it goes. But you're trying to construct the edges and you have is it shortest or yeah the short because there is a version where it's just like boolean, right? So that's what I'm trying to double check. But it is the shortest path in the graph and it is what it sounds like. Yeah, I think that's mostly the idea behind this one. Yeah, and let's see if there's any. Okay, so n is 5,000. So at worst, it's going to be n squared for like a, because breadth first search or something like that is going to be v plus e, and e in this case could be 5,000 squared. Though technically speaking, it's very unlikely that that's the case. But yeah, but we still have to do it in a smart way, right? Because if actually maybe not, I guess, because the length is only 10, though 5,000 times 5,000, I guess over 2, so that's what, that's 12 million times 10, so that's going to be like back of the envelope 120, what did I say, 125 million. That's probably going to be too slow, so we can do some sort of lookup situation, but it's still a little bit awkward to be. Let's see, right? There's 5,000 words, there's 10 characters. That means that we can generate a lookup, a one-off lookup dictionary or whatever you want to call it in 50. So there'll be 50,000 words times the length of 10. So like 500,000 characters or something like that. I guess that should be fast enough for space. I know that I actually don't do this very often, so hopefully this is informative in that I am solving this live and I'm going over my thought process on analyzing the constraints. Very often on Leetcode, but not necessarily real life or interview, is that very often in Leetcode, I find an algorithm and then I just know that it's going to be fast enough, which is my bad. I don't always do a great job of explaining things in my head because I've kind of done it many times. But yeah, for this particular one, I think that would be good enough. So yeah, so let's kind of see how that goes. Okay, so n-word has to be in there. But basically, we want to construct the edges in as fast as possible is what we want to do. It doesn't have to be an explicit edges. We can just look it up. But yeah, okay, so okay, so well, I was going to say if n-word not in word list returns 0. I guess that's I don't know that this looks very simple, but it's actually not that cheap. But it'll probably be fast enough. Okay, right. I mean, this isn't the only case, but I feel like that's like I don't want to worry about a case. But then now we want to say for word in word list, we want to construct, let's say, a lookup table that gives you the word. So here, lookup sub x means given a normalized form, maybe that's the way, I don't know, given a one-off word x, give me all the real words, right? That's basically the idea. And then here, maybe this is where yield would be nice, but this is kind of awkward, isn't it? At least to do in Python, because I think in other languages you can just like edit it and then do it again or something like that. but I guess maybe we have just to do for I and range of length of word. I don't know if this is really awkward though, but yeah, but this goes to I plus word of I plus 1. So this basically deletes the I character, but we in its place we can add like a, let's just say star, right? And let's point it out real quick just to make sure that we're that I'm doing the right thing. Okay, so this is, yeah, I feel like we are, because this is hot, right? And then this is da 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 da, and that, okay. So this is basically the key that we want, right? So this is the key, and yeah, and there is going to be some inefficiency here, but I guess if it's 5,000 times 10, that should be fast enough, even if we have an additional 10 factor or something like that. So then now we do lookup of key is append the word. So this basically is saying if you have this key, you know, you yeah. And maybe we could put this in a function though. I'm going to leave it not in a function only for premature optimization reasons, to be honest, because function in Python do add up over time if you do a lot of them, especially the way that Leetcode measures time limit exceeded, which is by the summation of time. So yeah, okay. So then now we start begin word, right? Does begin word have to be in here? This is really awkward actually, because begin word doesn't have to be in here, but all the other one does. Okay, fine. So then now we start a queue, and maybe just keeping track of best in a lookup table as well. And then now we start a queue as you go to collections dot queue or deck queue dot append begin word, and best of begin word is you go to 0. Sometimes I put this in a queue, an in-queue operation, but again, this time I think I'm a little bit conscious about the time complexity, because I feel like I have a vague recollection that in the past, this time limit exceeded for like silly things, so we'll see. But if I was doing it on like Codeforce or an interview, I would definitely have helper functions for these things. But yeah, but this is, at this point, to be honest, we're just doing standard web first search. So yeah, so that's basically it. So word is equal to q.pop left. Distance is equal to best of word, right? Just use that here. And then now we go for I in range of length of word. Just as we have before, we have key is equal to word I plus that's my sound for typing, I guess. Okay, so then now we go for possible next word in lookup of key. I guess we also do if key in lookup, though I guess it has to be by default because that's itself, right? But yeah, but why not for key, lookup? Yeah, then now the next word, we just append it, right? If it is good, if n word next word is not in best, then best of n word is equal to d plus 1. That's just regular, and then we append. Okay, right? And then now at the very end we return if n word in best, return n word of the other way. Why did I write it like that? But anyway, yeah. Otherwise we return 0. And we'll give it a spin. This is just web first search, so it should be maybe I'm off by 1 though. It is possible, because maybe I didn't count it. Let's see, 5 words, so it includes the original word, so fine. So that means that this is a 1. I just misinterpreted that. This is an easy fix, right? Because when we had 0, that is just that, you know, now that we're counting the number of words, the number of words is just the number of edges plus 1, right? So that's not that bad. Okay, so let's give it some mid. We'll see with time limits. That's my only concern right now, maybe. Actually, we did better than last time, which is actually hasn't been the case for the last couple of days. So yeah. This is very straightforward breadth first search, so it's going to be re plus ye-ish. The only thing that's a little bit awkward is the way to do this edge lookup, which I guess we can go over very quickly. So the length of Q is going to contain at most the number of words, right? So this is going to run O of n times, where n is the number of words. And each of this is going to be O of, how do you want to say, L for the length of the word, which is up to 10, I suppose. Technically, this is also O of L, so this is going to be O of L again. But this is, the thing with all these operations, though, when you try to think about it in terms of the length of the word, is that even this function, right? This is technically O of L as well, because you need to convert the key into hash, and that, of course, requires looking at every character, etc. So this is technically O of L as well. Though I guess it gets dominated by this, so maybe that's okay. And this is also O of L, for example. But this is the number of edges, which is, I mean, in total, it's in total, this is going to be adverse. This is going to be linear. So yeah, so this is also going to be O of n, I suppose. So yeah, so if you kind of look at it like this, then it is going to be n squared times L squared. Wait, did I? Kind of, right? Of course, it's very hard to. No, you could kind of construct this, right? I was going to say maybe this you can do some early termination, but really, this can yeah, you can easily make a case that kind of makes a timeout, to be honest, I think, using the summation of execution time thing. But I guess they're just a little bit kinder today on the complexity. But I think this is going to be the complexity. And keeping in mind that n squared is the ye part of v plus ye of the linearness, though technically that's not linear, but that is the size of the edges. So you really cannot do faster than that would be breadth first search. Any other way would require just other techniques. But yeah, yeah, this, I mean, we didn't analyze this, but that's also not good. This is going to be dominated by this, so I didn't say anything. Okay, for space, this is linear because, you know, we just have a lookup here. Is it linear? Actually, give me a second. I don't think that's linear because for each word, I guess this is just, let's see. Okay, let's think about this, right? How many keys there are possibly? So this is going to be O of n. For each one, there's O of L. So yeah, so the number of keys is going to be O of n times L at worst. So that's your space, or that's the number of keys, and each key can have n words, right? So that means that the total space is going to be n squared times L space, which is actually kind of more than I thought. But it really depends on the cases, I suppose. Yeah. Let me put them together. Cool. That's really all I have for this one. Let me know what you think. That's submit. Yeah, I guess I submit. Yeah. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this question. It looks like I'm half naked, but no, I just have a pink shirt. Anyway, stay good, stay healthy, to good mental health, and I'll see you next time. Bye-bye.